Hi there and welcome to our last edition of our C5 topic on quantitative chemistry, how much. Now in this lesson what we're going to be looking at is precipitation reactions. Now we have covered these before, but we're going to look at a few more examples. Anyway, I hope you enjoy this and I'll see you at the end. Okay, so here are our objectives for this lesson. By the end of this lesson you should know and understand how to produce a precipitation reaction and how to identify ions within a solution using examples of precipitation reactions. Precipitation reactions are when a solid ionic substance is formed from a solution of free ions. Now, the precipitation occurs because the solid that's made is insoluble. Now the precipitate is the product that is formed. Okay, so this is when the ions collide to react with other ions to form a solid within a solution. So how can we go about actually collecting the precipitation ions? Now I'm going to show you a quick method of how you can do this. Now we'll start by drawing a filter funnel. Now in the filter funnel you have filter paper. Now what you can do is you can put in the solution of the first set of ions, so we can put that in there. Then what you can do is you can add the second solution to it. So here we're going to just pour some yellow stuff, that's the scientific name for it, into the original mixture. Now what will happen then is at the bottom here you will end up with your solid precipitate. Now once you've got this solid precipitate you can do a number of things. The first thing you can do is you can take a bottle of distilled water that's got the tube like so. You can squeeze the water and you can wash the product, and what you'll collect in below the funnel is you will collect distilled water and some of the spectator ions that are not involved in the reaction. Now once you've got the filter paper here that's got the solid in, you can take that solid, you can put it into an oven and you can dry that at about 50 degrees C, and that will allow the solid precipitate to dry and be able to be used. Now detecting ions is relatively straightforward. Now the halogens, which are in group 7, which we covered in C4, actually can be detected by using one particular chemical. That chemical is lead nitrate. Now when you add lead nitrate to a solution that contains a halogen or a halide ion, it will form a precipitation reaction, and we can see with this reaction here. Now a couple of things that we need to be aware of. Here AQ is the state in which it's in. So here lead nitrate is aqueous, which means it's dissolved in water, as is the sodium chloride, with the chloride being the halide ion. Again, that's aqueous. Now when you add these two together we form lead chloride. Now lead chloride is insoluble, so it therefore becomes a solid, as does the the sodium nitrate remains aqueous. Now you can add lead nitrate to all the different halogens or halide ions, and this is how you can detect them. So if you were to have chloride, this lead chloride solid here would be a white precipitate. If you were to do it with sodium bromide, you would get a cream precipitate, and with the iodine or iodide you would get a yellow precipitate. Now when we looked at the previous section, we looked at detecting ions. Now it's not just the halide ions that we can detect, we can also look for sulfate ions. Now here we've got the sulfate ion here, which again is dissolved in water, and to test that we can use barium nitrate. Now barium nitrate will form barium sulfate, which is a solid. Now barium sulfate is actually used as a barium milkshake drink used in taking x-rays. Now if we were to look at the equation for this, we would see that the sulfate ion here, the barium ion here, they connect to form the solid equation. Now we're going to have a look at a couple of examples here. The first one we're going to look at is this reaction here, which we looked at the previous slide. Now here we have lead nitrate reacting with sodium chloride to form the lead chloride and the sodium nitrate. Now you'll notice here we've got aqueous, aqueous, solid and aqueous. Now I'm going to show you the same reaction but a slightly different version of this. Now this is what we call an ionic equation. Now here we've got the lead ion, we've got the nitrate ion, the sodium ion and the chloride ion. Now on this side we've got the solid lead chloride and the sodium ion and the nitrate ions. Now if you notice here, the sodium is exactly the same on both sides as is the nitrate ion. So what we can do is we can cross out the nitrate and the sodium on both sides. Now the reason we do this is because they are spectator ions and they have no involvement in the actual reaction. They stay as aqueous ions all the way through the reaction. Now earlier on we looked at the reactions of the lead nitrate with the halogen ions or halide ions to form solids. Now what we're going to show you here is the ionic equations for those reactions. We're also going to look at the ionic equation for the barium with the sulfate ion. Okay, so the first one we've got lead ion with a chloride ion to form the lead chloride. Notice how the charges here, we've got a 2 plus and a minus, so therefore you need 2 chloride ions to balance that out, and therefore we get the formula PbCl2. The next one, which is the same with the bromide ion, it follows exactly the same pattern as does the iodine. So we've got 2 iodide ions to make lead iodide. Now the last one, barium sulfate, here we've got the Ba2 plus and the sulfate ion is a 2 minus ion, and therefore that balances out to become a 1-to-1 ratio, so you've got 1 barium ion and 1 sulfate ion forming that solid. Okay, so that concludes our C5 topic, the last lesson here on precipitation reactions. We have looked at how we can extract a precipitate from the reaction. So we need to wash it with the distilled water and then dry it in an oven around about 50 degrees, not too hot, otherwise we might start to cause thermal decomposition reactions. We've also looked at the reactions of the halide ions when they form precipitates. Remember, chloride is white, bromide is cream, and iodide is yellow. And then the last one we've looked at is the barium with sulfate, to form barium sulfate. And we've also focused on the ionic equations for those, and it is important that we also remember the state symbols. Anyway, I hope you've enjoyed this topic, and I will see you again for the next one. Take care, bye-bye.